Good morning, all. Build on your previous discussion about series and parallel circuit. Today we are to say about Kirchhoff's law. So let us see what is Kirchhoff's law, what is KVL and KCL. For that we can recall it. We saw about what is conductor resistor and what are the energy storage devices. What is serial and parallel circuit is, how it has been calculated. What are the formulas for calculating the series and parallel circuits. So in today's topic, let us discuss about the fundamentals and history of the Kirchhoff's law and the Kirchhoff's current law, Kirchhoff voltage law, and applications in current analysis with real-world example and advanced concepts. Okay, so let us see what is Kirchhoff's law. So it is an introduction to the electric circuits based upon the basic components with respect to resistors, voltage, current, and sources. So Gustav Kirchhoff invented the Kirchhoff's law in 1845 based on the conversion of charges and energy. So why it is so important? Because the foundation of analyzing a complex DC circuit beyond the Ohm's law, we go for Kirchhoff's law. So the Kirchhoff law is of two types. That is one is based on the current, and the one is based on the voltage. So this is the example for Kirchhoff's current law, and this one is example for Kirchhoff's voltage law. Let us see what is Kirchhoff's current law. So the Kirchhoff current law is something that at any node or junction, the sum of current entering is equal to the sum of current that is exists. So here in this diagram, the current which enter is I1, I2 and I6. So here I1 plus I2 plus I6, that is equal to I3, which the current outgoing, I4 and I6. So the summation of current entering the node, that is equal to the current left the node. So based on the conversion of charge. So the example equation is that I1 plus I2, that is equal to I3 plus I4. Based on this diagram, I1 plus I2 plus I6, that is equal to I3 plus I4 plus I5. So this is a simple node examples. Let us see what is Kirchhoff's voltage law. So in Kirchhoff's voltage law, in any closed loop, the sum of voltage drops, that is equal to the voltage rises. So the summation of voltages, that is equal to 0 based on the conversion of energy. So here the voltage source is equal to the voltage across the resistor R1 and the voltage across the resistor R2, and that will be equal to 0. So the voltage across these three resistors will be equal to zeros, and here if we take this example, the voltage across A, B, C, D and E and F will be 0. So this is the second law. One is about Kirchhoff's current law, then this is the Kirchhoff's voltage law. So here this is an example for direction of travel of the current. So through a resistor, the current passes through from A to B. So the summation of voltages, that is V of B, voltage at the terminal B and voltage at the terminal A, that is equal to the current. So here also the same, how the direction of travel. So it is negative IR and here it's positive IR. So similarly for voltage also, how the voltage across the terminal is occurs. So it is positive and negative. Next, let us see the empathize of the Kirchhoff's law. So what is circuits? Here the system that power devices like phones or light, that is said to be your circuit, where the resistive loads are depends upon the load conditions. So here the rules to predict how electricity flow like water in a pipe. So the empathetic example is imagine planning a family budget. So here the money is equal to the money out. So like a current in a circuit. So the current flow inside the circuit, which is equal to the current flow outside the circuit. So whatever money we earn, we spend. So it helps design use of daily lives. Example. Next is DC circuit components. Here let us see the defined part. So in Kirchhoff's law, the fundamental principle of physics used to analyze the electric circuits, and there is no connections to empathy. The user queries combines the physical concept with physiological one and indicates the misunderstanding of the terms. Next, let us see the application of the circuit analysis. So here the application of the circuit is electronic design, example smartphones, the power systems and machine node analysis, we are using it. The main limitation of this law is it assumed that lump elements not for higher efficiency or nonlinear circuits and also advanced. So it is mainly for mainly can be calculated with the help of superposition theorem and simulation software like Spice and PSpice and you can also say about multisim. So design a home lighting system using a KCL so that the current displays correctly and also balance the voltage. So let us summarize. We saw what is Kirchhoff's law and what is its first law is about Kirchhoff's current law and second one is about Kirchhoff's voltage. And in Kirchhoff's current law, the total current charge entering the diode or node is exactly equal to the charge that is leaving the node. So this is the example. So the summation entering and summation is existing is equal. So and here in a closed loop, the summation of voltage is equal to 0. That is the Kirchhoff's voltage law. Let us see a few examples with this help of Kirchhoff's current and voltage law. At any node, the current entering are 4 amp and 6 amp, and current leaving is, we have to find it. So the current entering is this much, means the current leaving also will be summation of these two currents. So that is 4 plus 6 is equal to 10 amps. And next question is that at a junction of 10 ampere current enters through the junction is 10 ampere. Two currents leaving from the junction, one is 3 ampere, another one is I. We have to find the I. So you know the total current entering is 10 amp and the current leaving is 3 amps. So 3 amps plus I, that is equal to 10. So the current leaving through the another current you are leaving here is that I equal to 70. I hope with this basic example you understand what is how to calculate the current entering and leaving the session. These are the reference. If you have any doubt related to this topic, you can feel free to approach me. Thank you.